Okay, guys, so now we're on to section 1.7. We're going to talk today about functions, okay, functions as rules and tables. Okay, here's your definition of what a function is right off here to the right. A function consists of, okay, a domain and a range, as you can see is highlighted there. All right, domain is also known as your inputs. The range is also known as your outputs, okay, and the inputs, the pairing of inputs with outputs such that each input is paired with exactly one output. So to explain that a little bit better, it's what we like to call a one-to-one correspondence. Okay, that's what that means. And I'm going to give you some examples of what I mean in a second. So a one-to-one correspondence. So you have a domain, which is otherwise known as your input. When we start talking about equations, that's typically your x values. And then you have a range, which is your output, which is typically your y values. Most equations involve a y and an x, okay? So we'll stay with y and x for today just to avoid any confusion. So if we were to talk about some real life examples here, guys, of what a function is or is not, okay? If I gave you a microwave on one end and I use Google on another end, okay, which one do you think would be considered the function? I'll give you a chance to think about that for a minute. Okay, now if it's a function, that means it has a one-to-one correspondence. That means that each input has to have one and only one output, right? Exactly one output, like it says up there. So I'm talking about a microwave and Google. Which one, when you input something, gives you only one output? Hopefully, you guys are saying the microwave. It is definitely the microwave and not Google. Okay. The reason it would be the microwave, if you wanted to microwave a Stouffer's French bread pizza and you put in one pizza, you're going to get out one pizza. That pizza is going to be hotter. Obviously, it's going to be cooked, but you put in one, you got out one. Sometimes you might want to microwave like mini pizza bagels. Okay. That's still a one-to-one correspondence because if you put in six and you get out six, 6 to 6, 6 divided by 6 is 1. So it's still a one-to-one correspondence. Google doesn't work because if you Google something, right? If you went home tonight and you Googled, the NFL, the National Football League, it's going to give you websites, photos, videos, links. It's going to give you every bit of information, pages and pages of information on the National Football League. So you're inputting one topic and you're getting out a whole bunch of outputs. That would not be a function. So hopefully that kind of helps you understand what a function is. We talk about domain and range and input and output. We look at this first example here. It asks us to identify the domain and the range. It gives us a table. The input is gallons. The output is dollars. So my input, which is those set of values right there, those are the numbers that are going to represent my domain. So your domain are the numbers 10, 12, 13, and 17. Your range, okay, your range are your outputs. So your range are those numbers down there. 1999, 2399, 2599, and 3398. So when they ask you for the domain and the range, all you're doing is listing your inputs and your outputs. Okay, that's all you're doing. Nothing any more complicated than that. Okay, moving right along. Okay, another example here. Identify the domain and range of the function. Same idea here. The domain is going to be the numbers that are your set of inputs, 0, 1, 2, and 4. Your range is your set of outputs. Now, there are 2 2s in the outputs, okay? If you have a number that repeats itself in the outputs, you don't have to list it twice, okay? You don't have to list it twice. So my range would be 5, 2, and 1, okay? So when something repeats as part of a set, you don't have to double up on it. You don't have to say it twice. Mentioning it once is good enough. Now, the next definition here, mapping. A mapping diagram looks something like this, okay? You're going to have one circle on the left. That circle is going to represent your domain. You're going to have another circle on the right. That number is going to represent your range, okay? In the domain box or the domain circle, obviously you put the numbers that are in your domain, the 0, 1, the 2, and the 4. In the range, you'd put a 5, a 2, and a 1, okay? And then you draw a map. So 0, because 0 is paired up with 5 in my input-output diagram, that's where I map 0 to. 0 maps to 5. 1 is mapped to 2. 2 is also mapped to 2. And 4 is mapped to 1. Okay? 1 goes with the 2, 2 goes with the other 2, and 4 goes with 1. Okay, now, is this a function or not? If this is a function, each input has to have one output. So each input can only be mapped to one output. Okay, so if I was to take a look at this one, 0 is mapped to 5 and only 5. 1 is only mapped to 2. 2 is only mapped to 2. It doesn't matter that they're going to the same place. That's okay. They're still only going to one spot. And the 4 is going to the 1. So this would be considered a function because of its one-to-one correspondence. So this is a function. Okay, let's look at a couple other pairs here. Tell whether each pairing is a function. Okay, let's look at the mapping in part A there. Do you see a one-to-one correspondence there? Does each input go to one and only one output? Hopefully, your answer is no, because of that situation right there. 0 is going to 2. 0 is also going to 3. So the input 0 has 2 outputs. So this map is not a function. Let's take a look at this input-output table. If I was to turn this table into a map, 0 is being mapped to 0, 1 is being mapped to 2, 4 is being mapped to 8, and 6 is being mapped to 12. That's as one-to-one as they get. This is a function. Okay? Moving right along. Now we're going to talk about, well, we got some more tables here, some more practice with telling whether or not the pairing is a function. I'm going to leave you to try these on your own. Okay, so I'm not going to go over these together. Maybe, one day when you're in class, we'll take a look at these, but I'm going to leave you to try these on your own and determine for yourself if these are a function. Okay. Writing a rule for a function. This is the last thing we're going to cover in this section. Okay. A verbal rule, I'm not necessarily concerned about what the verbal rule is. When they give you an equation, okay, like I said earlier, guys, typically they're going to give you an equation with an x and a y. Okay, in this case, they give us y is equal to x plus 3. Okay, now if you look at your input-output table, the input-output table is a table of values that represents what's going on in the equation. The equation is saying x plus 3. So each x is going to have 3 added to it. So if I look at the first pair, 0 plus 3 would be 3. 1 plus 3 would be 4. 2 plus 3 would be 5, and so on and so forth. So that is a table representing what is going on in our equation. Now, if we wanted to make a table on our own, let's say I gave you another rule. Let's say we wanted to go y is equal to, say, 3x. All right, let's say that was the equation for our function, and I wanted to make an xy table out of that, which obviously you can. Okay, your inputs can be whatever you want. Think about it, guys. When you go to Google something and search something on your laptop or your Chromebook, okay, you can search whatever you want. You have the freedom to choose whatever you want. So I'm going to pick 0, 1, 2, 3, and 4 as my inputs. Those are the 5 easiest numbers to use. Now, for your outputs, you need to apply the equation. So this is saying y is equal to 3x. Y is equal to 3 times x. That means I got to multiply each of these x's by 3. 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. And 4 times 3 is 12. So that would be a table to represent that function. Okay, now let's try and work in reverse. In example number 4 here, they give us a table. They want us to write a rule. They want us to come up with y is equal to, and they want you to tell me what is going on from x to y. What is happening to the x's to make the y's? Okay. I don't want to tell you to guess and check. Okay, but the first thing I would try and do is try and apply simple addition and see if you can find a pattern that works. For example, from 0 to 2, you would add 2. Okay, 0 plus 2 is 2. See if that pattern holds up. Is 1 plus 2 equal to 3? It is. Is 4 plus 2 equal to 6? It is. 6 plus 2 is 8, and 10 plus 2 is 12. So my rule here is that you're adding 2. So my rule is y is equal to x plus 2. Over here with this time and pay chart, okay, they want us to do the same thing. They want us to write a rule for the function, identify the domain and range. We're going to write the rule first. So it's going to be y equals, okay, and we're going to see what's going on with the x's and the y's. If you were to check simple addition from 1 to 8, that would be 1 plus 7. If you try to apply that rule over here, 2 plus 7 is certainly not 16. 2 plus 7 is 9. So that rule is out the window. Hopefully, if you look at the numbers, guys, look at my outputs. My outputs all have something in common. They're even numbers. They're divisible by 2. They're also divisible by 4. They're also divisible by 8. They are multiples of 8. 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. And 4 times 8 is 32. So my rule is you're multiplying by 8. You're taking the x and you're multiplying it by 8. So the rule is y is equal to 8 times x. That would be the rule for that function. Your domain is the list of your inputs, 1, 2, 3, and 4. And your range is your list of outputs, 8, 16, 24, and 32. All right, guys, so just some basic concepts on functions. The main thing here is that functions have a one-to-one correspondence. You cannot have one input going to 2 outputs. That's no good. All right, that's no good. Okay, so good luck and reach out if you have any questions.